Welcome to Evolve, a platform for machine learning enthusiasts. Now, today we will dive into the world of SVMs and explore how they can help us solve classification problems. Specifically, today we will focus on support vector classifier. Now, going deep into the SVM, first we should know what SVC do and how it separates the data. So, SVC comes under SVM library and it is used for classification data. See, SVC is a supervised learning model, so it can only work with labeled data. So let's take the example of from this graph. So we have two types of data here. So the ones here is black dots and here are white dots. So from this picture we can simply understand that the data is separated by a line. So how this line comes? How can one understand that where is that line which separates the data? So this line is made using the SVC classifier. Now, let us take an example that if you have a data separating animals, and just for an example, we have only two animals to say, like dogs and cats. Okay, so a simple line could be made separating the dogs and cats. But what about we have a line separating lions, cats, and dogs? Now, this type of example can come under the category of high dimensional data because lions are also considered as a cat. Now, for these type of general problems faced, we can use SVM kernels. Uh, uh, for this linear dimension, for two dimensional data, we can use linear kernel. But for high dimensional data, we can use many different kernels present, like hyperbola kernel and many other present. Now, to understand the practical implementation, we will take iris dataset, which is a dataset based on flowers. So, first we will import pandas library as PD. Then we will import the dataset into a data variable using read CSV. Now, using data.info, we will collect all the information related to the dataset, like what is the data type and if any objects are present there or not. So in this iris dataset, I'll show you later. Uh, the dataset is divided into five categories. Uh, one is one is sepal length, sepal width, petal length, and petal width, and finally the fifth one is species. So in the next slide, so here you can say that in the features, we will specify the sepal length, sepal width, petal length, and petal width in a list. Since SVM is a labeled data, and this data set is also a labeled data set, therefore we know that uh, we know the labels, so we can classify them before. But for many different models, different ways are used. Now, in this data set, what we do is we take input, general input like sepal length, sepal width from the user, and then predict the species of the plant. Now, for the prediction class, obviously we will take species. Now, from in X, we will take all the feature values like for sepal length, sepal width, petal length, petal width. We will take the values present in the dataset in the X variable in the form of arrays. Now, in the Y, simply we will take that values of the species. The next slide. Now, from using the library sklearn.model selection, we will use train test split. Now, this train test splits our dataset into two categories. One is training, another is testing, and it splits in the ratio of whatever you need. it is advised to split the training testing part in such a way that the training part is more and the testing part is less, because more you train your model, the more accurately it will give you results. Now since here you can see that the testing size is only 0.30, like 0.40 is your training part and the testing part is only 0.30. So this suggests that this suggests that um, 70% of your data is used in training the model, and rest 30% is used for testing the model. Now in the next slide, this part is not of that use, is it just helps you to understand what training testing part did. See, here you can say that the testing part is always less than the training part, since we took training testing in that ratio. Now, this is the most important part where we implement our model. Now we import SVM from the sklearn, and we made a CLF variable where we define our model svm.svc. Here, SVM is the library and SVC is the model. Kernel linear, since the data set is not multi-dimensional or high dimensional, it is a two-dimensional data, so nothing more could be expected. Therefore we are using the linear kernel. Now we will fit the training part into the classifier, that is into the model, and for the next step, for the predicting part, we will predict the data using the testing part. So our training testing will be easier. Now what will happen here is that prediction prediction will randomly choose different datas from the testing part, and the output will be given, and it will be checked, and therefore your accuracy will be predicted. Now from sklearn we will import the metrics class where we have an accuracy score. So this accuracy score helps you to understand how accurate your machine learning model is predicting the output. Now, since this iris dataset is very refined data, it has a lot of work done in it. And if you search in the research fields, if you are a little bit of interested in that field, you would be knowing that iris is the most basic data set that we have taken here to get you a better understanding. Therefore, the accuracy achieved of this data is 97.77%. Now, we have come to our VS Code. Now, I'll explain you the code, the actual code which we have written, and I'll also show you the data set. So this is the iris data set. Huh. So these are the sepal length, sepal width, petal length, and petal width. Now there are around like 150 different types of data on the basis of which these different species are defined. Now you can say for each different combinations there is a different species. Now first we will we will import pandas library. So I'll just run the code. Okay, now we will use pandas read csv function, and import this dataset into the data variable. So I have done it. Now I'll just check the information. So here you can see that there are total 150 of different data with all not null. This suggests that each category has a data and it is not empty, and each data type is float. Only the last one, the species one, which is a string, you can see is defined as an object here. Now so in total there are in each row there are 64 there are data types of float 64, and four different float 64 are there, and one object. Now as I explained earlier in the slide, feature is defined with sepal length, sepal width, and petal width with the features name, and prediction class is given as species. Now just make sure that when you are defining features and prediction class, this should be similar to this, means this should be exactly same, or else our code will generate an error. Like if I just instead of small s, I just give a capital S and just try to run it, So it just ran here, but while I'll be running this code, it will generate an error. See, index error. It gave this not an index. So for this to be an index, I'll just make it small. I'll run the snippet. I'll put the values in x and y. Now see, no error came. Now I'll split the data and get the shape of x test and x train, y test and y train. So as we can say, we have got the x test, x train, y test, y train. Now depending on the test size, we are getting this. If we reduce the size to 0.2 and then run it again, then you can say the shapes are changing. Now we will import SVM from sklearn and use the kernel as linear. The reason I explained in the slide. Now, since this CLF is our machine learning model, we will fit the X-test and X-train and Y-train data in it, and in the Y-pred, we will use X-test to get the values in Y-pred. So I'll run this. Okay, we have got a warning here. The column vector was passed when a 1D array was expected. Okay, so we'll just ignore this. Now we will move to the next snippet, where next section where we have defined the accuracy score. The accuracy score is calculated on the basis of y test and y pred. Like for certain x values, not x train, not x test. For complete x, for complete data, we are considering x. So for that complete x values, what different y test values and what are the y pred values, and if they are same, then the accuracy is calculated. If they are not same, then it is returned false and the accuracy is reduced. So as much more they are same, the more is the accuracy. Now let me run this. So I've gotten 100% accuracy, but if I reduce the size here, if I reduce the size to 3, then let me run this. See the size, see the shapes changed. I'll run this and I'll run this again. See, the accuracy is 95. Now for different test size, I'll get different accuracies. Let me just do it for 40, for sorry 40%. The shapes changed again. Now just see, the training data has reduced and the testing data has increased, but still training is more because it is considered a good practice. See, it is giving only 95%. So the from here we can see that the more will be our training data, the more accurate will be our model. Okay, so now for the concluding part, we could say that our model trained in using the linear kernel is predicting these species of flowers very well. That is Iris setosa, Iris virginica, Iris versicolor. Now these three species present in the dataset are predicted based on their sepal length, sepal width, petal length, and petal width. Now, uh, SVM can work really good with small data set, but using this on large data set could take a lot of time, and the results yield will be not good. So, thank you for watching. Please wait for our next video, and thank you, and happy learning.